The long-range LRIT system is a designated international maritime organization system designated to collect and disseminate the vessel's positions, information received from IMO member states ships. The main purpose of the LRIT ship position reporting is to enable a contracting government to obtain ships' identity and locations by a ship of its coast and to respond if necessary to reduce any risk. The LRIT regulation apply to the following ship types engaged on international voyages: all passenger ships including high-speed craft, cargo ships including high-speed craft of 300 gross tonnage and above, and mobile offshore drilling units. Vessels are required to automatically transmit their identity, position, date and time of the position at 6 hourly intervals with an ability to increase the rate of intervals of up to once every 15 minutes when requested. It is a satellite-based real-time reporting mechanism providing almost worldwide coverage, that is in-basket coverage, that allows unique visibility to position reports of vessels that would otherwise be invisible and potentially threat. There are two aspects to LRIT: the reporting, the receiving aspect. Okay, the reporting aspect, where vessels to which LRIT applies report their identity, position, state and time every 6 hours, 4 times per day. The receiving aspects, where coastal states can purchase reports when vessels are within 1000 nautical miles, or where port states can purchase reports when vessels seek entry to port entry at a predetermined distance or time from the port. Describe the LRIT system and its component. The LRIT system consists of the shipborne LRIT information transmitting equipment, the communication service provider, the application service provider, the LRIT data center including any related vessels monitoring systems, the LRIT data distribution plan, and the international LRIT data exchange. Shipborne LRIT equipment. The shipborne equipment should be set to automatically transmit the ship's LRIT information at 6-hour interval to the DC identified by the flag administration, unless the contracting government requesting the provision of LRIT information specifies a more frequent transmission interval. Communication service provider. The communication network used for LRIT are Iridium and Inmarsat C and D+. The satellites are operated by a communication service provider which provides the communication infrastructure and services to link the various parts of the LRIT system using communication protocol in order to ensure the end-to-end secure transfer of the LRIT information. The data is then transmitted to the application service provider. In India, Tata Communication are the communication service provider, that is CSP. Application service providers receive the LRIT reports transmitted by the ships via the CSP, adds a certain additional information to each report and forwards the reports to the data center nominated by the ship's flag state. The information to the added to each LRIT report by the SP includes ASP ID, CSP ID, message type, IMO number of the ship, MMSI number of the ship. Application service provider for India is at the National Data Center at DG Shipping, Mumbai, developed by Antrix SEC. LRIT Data Center. The LRIT Data Center collects and distributes data to the contracting government according to the data distribution plan, which defines the rules and rights for access. The LRIT Data Center also interact with the LRIT International Data Exchange. LRIT Data Center for India is the National Data Center at DG Shipping, Mumbai. LRIT Data Distribution Plan. It defines the rules and assess the rights. The DDP server is managed by IMO and it's populated by SOLAS contracting government. Following the IMO technical specification, the DDP is consulted by any data center in order to determine whether a request for LRIT information should be allowed under the rules for the distribution of LRIT data. International Data Exchange. The international data exchange refers to the sharing of LRIT information between different countries and then LRIT data centers. Route LRIT information between LRIT data center using the information provided in the LRIT data distribution plan. Be connected to all LRIT data centers and the LRIT data distribution plan server. Who has access to the LRIT data? Flag state, full access to all ships under their flag. Coastal state, access to enhance the LRIT information and reports. Coastal state can poll and track ships up to 1000 nautical miles from their coast, but not if the vessel is in territorial waters of another state. Port state, access to enhance the LRIT information and reports. Port state can poll and track the ships at any distance following a notice of poll call, usually up to 96 Hz pre-entry, but not if the vessel is in territorial water of another state. Ship owner, access restricted to own ships. Surveyors, restricted access to verify the LRIT, confirm its LRI test, agents and charters, selective access if granted by ship owner. Piracy prevention task forces access via the special format. SAR services authorized may request, basically flag state, coastal state, port state, ship owner, surveyors, agents, charters, piracy, and SAR can get the LRIT data. Okay. Radio detection and ranging radar. The switch. What is the performance test? How to perform it on the radar? The switch is provided to check the overall efficiency of the set. When this switch is put on, a plumb or a sun pattern appears on the screen while on 1.5 nautical mile range or other small range scale specified by the manufacturer. The length of the plumb is measured with gain set normal and both anti-clutter and differentiator control set at minimum. The present length of the plumb expressed as a percentage of the maximum length in the past gives the present relative efficiency of the set. The procedure to check the efficiency: perform the PM test. Switch on the radar set and get a picture. Change over to a range scale specified by the manufacturer, usually 1.5 range scale. See that the PL selector switch is in the short pulse positions. See the clutter suppression and differentiator controls to minimum or off the position. Set gain as usual. Operate spring loaded performance monitor switch, and a feather or a chart wheel pattern will appear on the screen. Measure of the maximum length of the feather with the help of VRM, and any error of the VRM must be allowed for. Relative efficiency equals to present length of feather multiplied by 100 divided by maximum length in the past. If at any time the relative efficiency drops below 80%, any investigation of the causes must be made. Some of the very simple causes could be water or dirt in the waveguide, salt or dust on the scanner, improve the tuning, etc. If the cause is not as simple as that, the help of technician may have to be sought. Meanwhile, a record of the length of the feather and the maximum detection ranges of targets obtained should be kept. What are the constraints imposed by the radar range scale in use? The constraint imposed by the radar range operator of the Colrec Rule 6. A safe speed, for example, if a vessel is using a short range scale, it may not detect target a greater distance. Exactly. Short range gives good resolution and also detection, due to which early warning of risk collision cannot be obtained. Long range sacrifice detail to gain early detection. Two or more set is a different range scale on each set. It is the best for switches regularly if the ठीक है. Limitations of the radar. Same. It is the ability of a radar set to clearly distinguish two small targets on the same bearing and slightly different ranges as two separate on the PPI. The factor that governs this is pulse length, which causes all paint to expand radially outward by half PL in meters. Considering the two small targets that are all on same bearing are close to each other, the paint of the nearer target would expand towards the other on the PPI by half PL in the meters. If the distance between the two is equal to or less than half pulse length, their paint would merge on the PPI. Where what is the length of the PL? Pulse length. If the target are further apart than PL, half PL, they would paint as two separate targets further apart than half PL. What is the value of PL then? Determine bearing discrimination. It is the ability of a radar set to clearly distinguish two targets on the same range and slightly different bearings as two separate targets on PPI. It is the ability of the radar set to clearly distinguish two targets on the same range and slightly different bearings as two separate targets on the PPI. The government factor is the horizontal beam width of the set. The governing factor is the horizontal beam width. Different bearing as two different targets, the same way slightly different bearings. Okay, SBW causes all targets on PPI to expand in azimuth by half HBW on either side. The paint of the two targets on the same range and slightly different bearings will therefore expand towards each other by a total of 1 HBW if the angle obtained at the scanner by the close edges of the two target is equal to or less than HBW. Their paints would merge on the plane position indicator and they would appear as one big target. Minimum range detection of radar depends on the following factor. The pulse length. Same waveguide and scanner is used for transmission and for reception, and unit called the transmission reception TR switch is fitted. This unit blocks the receiver branch of the waveguide during transmission to prevent the transmitted energy from short circuiting into receiver and damaging it. The TR cell therefore ensures that reception starts only after transmission is over. When transmission starts, the tracing spot leaves the center of the PPI on its radial path. By the time transmission is over and reception starts, the tracing spot would have traveled a radial distance of half PL in meters. Hence, target closer than half PL in meters cannot be shown on PPI because the echoes will come back before reception starts. The deionization delay. A small delay occurs in the TR cell below the completion of transmission and commencement of the reception. This delay increases the minimum detection range VBW and the height of scanner. VBW and the height of scanner above sea level affect the minimum range, as these two factors governs the distance of at which lower edge of the radar beam will strike the sea surface. The VBW of a given scanner is fixed, whereas its height above the sea level depends on the ship's draft at that time. The higher the scanner above the sea level, the greater the minimum the range of the detection. The greater the minimum range of detection of the radar set and vice versa. What is wavelength? The minimum detection range of small target is better than when using 3 centimeter waves than wave using 10 centimeter waves. When using 3 centimeter than using 10 centimeter, the minimum detection of small target is better than using. Okay, maximum range of a radar set depends on the following characteristics of the radar set: height of scanner. The greater the height of the scanner of a series, the greater will be the detection power of the set. The greater the power of transmission, the greater the expected maximum range, subject to other factor mentioned here. The wavelength: 10 centimeter waves have a great maximum range than 3 centimeter waves due to less attenuation in the atmosphere and more diffraction and more diffraction. Pulse length: long pulses ensures better better maximum ranges than short pulses. This is because the long pulses have more energy in them than short pulses and hence have a great ability to suffer attenuation in the atmosphere. Long pulses ensure better maximum ranges. Okay, VBW and H. The narrower the beam width, the greater the directional concentration of the transmit energy and hence the greater the maximum range. Range accuracy of radar depends on correct synchronizations between the transmission of the pulse and the commencement of the trace. Height of scanner when observing small targets very close by radar. Measure the range from scanner to the target, where correct range should be distance along the surface of the earth. Bearing accuracy of radar depends on correct alignment between the heading marker and the scanner and the marker and the bearing scale. Gyrograph: anyone displays gyro stabilized. Type of bearing marker used: rectilinearity of the trace, beam with distortion, scale size of the spot. Now speed over ground. The speed over ground of the ship with respect to the sea bottom over the time. The speed of the ship with respect to the ground or any other fixture such as buoy or island. The speed of ship with respect to water such as anything floating on waters. Speed through water with respect to the water such as anything floating on the water. The speed of the ship with respect to the ground or any other fixture such as island. The speed calculated by comparing previous position fixes over time. The speed of with respect to the water such as anything floating on water. Okay. Speed to use for collision avoidance. Speed used for radar collision avoidance should be speed through water since it provides a more accurate indication of vessel's target aspects. It must be remembered that colorics are based on how we see the ship, not on how they are moving. Using SOG will give a false indication of ship's position as it shows course made code. True motion or relative motion, what should we use for collision? True motion or relative motion? I guess relative motion is more kind of good. A true motion display is one on which origin moves across the radar screen at the course and speed of the own ship. The course is fed in directly from the gyro compass, where the speed is normally fed in by log but may be fed in manually. The movement of all targets on radar screens are true. Stationary targets remain stationary and all. The origin may be shifted anytime to any convenient part of the radar screen as decided by the observer within about 75%. Relative motions. A relative motion displays is one in which a stationary spot called the origin or electronic center represent the position of the own vessel while all other targets move relative across the radar screen. The relative movement apparent course and speed of each target on radar is the resultant of its actual course and speed and reversed course and speed of the own vessel, such as that even stationary targets move on radar screen with course and speed position to that of the own vessel. The origin is normally centered over the radar screen, but but the origin is normally centered over the radar screen but may be shifted off center if desired by the observer. As far as collision avoidance, relative motion is deemed situable as it provides the movement of other vessels in the vicinity relative to own vessel, which gives a clear picture to the observer about the situation. Sea stabilization. The movement of the origin is the ship's movement along the oops. The movement of the origin is the ship's movement through the water. Gyro course and log is fed. Speed is speed. Self-stabilization. The movement of the origin, that is electronic center, is the ship's movement through the ship. कहाँ गया द ग्राउंड स्टेबलाइजेशन? वापस से. द मूवमेंट ऑफ द ओरिजिन इज द शिप्स मूवमेंट थ्रू द वाटर, gyro course and log speed through the water, gyro course and log speed. If the influence of current causes and speed made good to somewhat different from the gyro course and log speed, it may be seen when causing that land body this is somewhat different from gyro course. This poses no problem for collision avoidance for navigation. The bearing and range of all of them are affected by this and okay. This poses no problem for collision avoidance. This poses no problems for collision avoidance or for navigation because the bearing and ranges of all objects are unaffected by these and hence correct. To put in briefly, on set stabilized display on all movement of all navigation because the bearing and range of all objects are affected by these and hence are correct. To put in briefly, all sea stabilized display all movements own ship fixed objects and their movement through the water. Ground stabilization mode should always be used in conjunction with true vectors because the GS mode takes input. GS mode, what is ground stabilization mode, takes from input and ground stabilization input or set. Ground stabilization in the input of certain rate of current is fed in whereby the movement of sea stabilization, ground stabilization. Right side can have the header display. Here then 12 o'clock position of the PP always represent own ships, people, course and has
the sextant the head up not display. Here the 12 clock VPI bit correct. Turn on the display and turn. The course up the north of display head up. Okay, the head up is unstabilized. 12-degree clock position of the PPI also reveals the one ship's course, and once the heading maker reveals at the zero of the fixed graduated ring around the PPI, all bearings are activated. The right side of the correction screen is display. The north of display, the north of display, the south of display. Ship the corpus, the course of the radar system ranges bearing up to 0.1 CPS. Again, control function should be provided on the system. North of display course, whatever course we are doing, it will come at the center of the level line facing our heading. And north of display is the heading which we are facing, and heading also the GPS. And so that